Without any further ado, Professor Sandeep, I request you to start the session so that we close on time.
Sure, sir. Sure, sir. Okay. Very good afternoon to all of our friends joining in from UK. Very good evening to everyone joining from India. And very good morning if there are guests from the US. And welcome, Dr. Yogesh. Welcome, Dr. Raman. Welcome, Dr. Arpan to this seminar series. Let me share a little bit of context because this is going to be the first one in a series of seminars on AI. So this series is actually inspired by various perspectives on artificial intelligence and its transformative potential, which were presented in a very recent perspective article by Dr. Yogesh Dwivedi and his co-authors, Dwivedi et al. 2019. AI offers a huge transformative potential for augmentation and possibly even replacement of human tasks and activities in a wide range of industrial as well as social applications. And what is amazing is the pace of change with new breakthroughs in algorithmic machine learning as well as autonomous decision making. This creates lots of new opportunities for continued innovation. The impact of AI can be very significant with industries and sectors ranging from fintech, FinOps, agriculture, healthcare, manufacturing, retail, supply chain, logistics, all of them could potentially be disrupted by the onset of AI technologies. So this seminar series will actually give us a lot of insights, and the seminar series is based on the digital future for business and society, perspectives on AI challenges and opportunities. And we will get to hear and learn from leading expert speakers who will highlight both sides, the opportunities as well as the challenges posed by the rapid emergence of AI. Let me share a brief introduction of Professor Dwivedi. So Professor Yogesh Dwivedi is Professor of Digital Marketing and Innovation and founding director of the Emerging Markets Research Center and co-director of research at the School of Management, Swansea University, Wales, Great Britain. Professor Dwivedi also leads the International Journal of Information Management as its editor-in-chief. And his research interests are at the interface of information systems and marketing, which is a very interesting area. So he focuses his research on issues related to consumer adoption and the diffusion of emerging digital innovations, digital government, digital and social media marketing, particularly in the context of emerging markets. Professor Dwivedi has published more than 300 articles in a range of leading academic journals and conferences that are widely cited. In fact, his citation number is more than 22,000 as per Google Scholar. Professor Dwivedi is an associate editor of the Journal of Business Research, European Journal of Marketing, Government Information Quarterly, and International Journal of Electronic Government Research, as well as senior editor of the Journal of Electronic Commerce Research. Let me now give a brief introduction to Dr. Ramakrishnan Raman, our Director, Dean Faculty of Management at SIBM and SIU. So Professor Raman has more than 18 plus years of total WorkX, which is a blend uniquely of both corporate, academic, and research experience. His professional career started with a large organization in India, Godrej & Boyce Manufacturing Company Limited, which is more than 100-year-old company in Chennai, India. He then moved to the consulting domain, where he led a company called Leading Edge Consulting Services. And he then moved full-time into academia to pursue and satisfy his passion for teaching by joining Vellore Institute of Technology in the Department of Management Studies. Following that, Professor Raman joined the Kohinoor Group in their business school located at Khandala. And the Kohinoor Group was offering the business management program of Carleton University Sprott School of Business, Ottawa, Canada. And during his long stint with the Kohinoor Group, he even took up the ERP implementation for the entire group's education division. Following that, Dr. Raman worked with the SP Jain Institute of Management in their Mumbai campus. So after a short stint at SP Jain, Dr. Raman joined Symbiosis International University more than 8 years ago. For the first half of his tenure at Symbiosis, Dr. Raman headed Symbiosis Center for Information Technology as director, and he took charge as director of SIBM from July 2014. Today, Dr. Raman holds many job titles in Symbiosis, not just director of SIBM, but also Dean Faculty of Management and many other roles in the university. He has traveled across the globe and has initiated academic collaborations with Swansea University and many other universities in Japan, Canada, UAE, and the United States. His main research interest is at the interface of information systems, information security, IT strategy, and digital marketing. Can I invite Professor Yogesh at this stage for your opening remarks, sir?
Thank you, Professor Bhattacharya, for such a nice introduction and long one. I just simply want to say, warm welcome to everyone who has joined today in this seminar, and hopefully will be joining in the remaining one in this series. We all know that AI is nothing new. It started in 50s and 60s, actually. It's actual technical development. But in terms of application, momentum actually has taken place very fast since last few years. So in 2019, we decided to do a workshop, which actually led to create an article on AI, multiple perspectives on AI and its applications and issues. And this seminar is basically extension of that. What we want to do is to create a broader collaborative network through these talks and associations. And hopefully, many of us might be working in future together. And reason to focus on is, AI is not just now important for academia. Lots of journals, editors, and reviewers really very keen to publish work related to AI, but also it's taking very fast-paced applications in practice and policy. If you look at government and various organizations, they are all are implementing some systems or applications that is enabled by AI. So I think it's becoming very, very important. So I think our hope from this seminar, which is jointly organized by School of Management, Swansea University. Those who doesn't know Swansea University, you can see in my background, this is the university campus based in Wales, UK, and SIBM Pune, actually. So we both jointly organizing, so the not only limited audience can benefit, but the audience from both India and UK and elsewhere. I can see lots of colleagues have joined from Europe, actually. So it can benefit everyone across the world. So warm welcome, everyone, for this seminar series. And I'm looking forward to you all and your collaboration with this seminar series for next 15 seminars. Thank you very much.
Sure. Thank you, Professor Yogesh. Dr. Raman, may I now invite you for your opening remarks?
Thank you, Professor Sandeep Bhattacharya. I think it's 6:40 here in India and about 1:10, 1:15 in UK there. I'll not take much time. First, let me thank Professor Arpan for taking out time. You are the opening batsman for us for this series. It's going to go till June, and formally welcome you to this and thank you for your time. And in fact, you're going to set the context for the entire seminar series where you're going to talk about evolution scope of AI, a beautiful start of series with your session. I formally thank Professor Yogesh for the opportunity to collaborate with Swansea and have this series, launched jointly by Swansea and SIBM Pune. So I'm sure that there are a lot of people who will use this video, which is getting recorded. Will be there on YouTube as well. We'll make it public in a day or two after we curate it. There are about 150 of them who are there on this Zoom platform, and it's getting streamed on YouTube as well. That will be available for all who missed the session now can see that later as well. So with those remarks, I think I will hand over the floor back to Professor Sandeep, who's doing a fantastic job of anchoring this. Thank you, Professor Sandeep. And we can get going if everything is fine. Thank you, Professor Sandeep.
Most welcome, sir. Thank you for those opening remarks. So, Professor Arpan, with your permission, allow me to give a brief introduction for you and then hand over the floor. So, Professor Arpan Kaur is Associate Professor in the Department of Management Studies, IIT Indian Institute of Technology, Delhi, India. He is the Chair of Corporate Relations and is in the Committee for Institute of Eminence. His research interests are in the interface of data sciences, digital transformation, internet ecosystems, social media, and ICT-based public policy. He has authored over 100 peer-reviewed articles and edited 7 research monographs. As of 2020, his research has been cited over 2,500 times. He has an H index of 25 and an I-10 index of 57. Professor Kaur is the current editor-in-chief of the International Journal of Information Management Data Insights, published by Elsevier. And this is a companion journal of the International Journal of Information Management, ABDC, A, impact factor higher than 8. He actively supports knowledge dissemination platforms like the International Journal of Electronic Government Research, Information Systems Frontiers, The Bottom Line, Advances in Theory and Practice of Emerging Markets, Global Journal of Flexible Systems Management, International Journal of Information Management, and many other publications. He also handles guest editorships in various journals. Prior to joining IIT Delhi, he has worked for IIM Rohtak, IBM Research, and Cognizant, one of the largest IT companies headquartered in the US. He has also handled a lot of research, advocacy, and training projects from national as well as international firms and governments, and has received numerous recognitions and awards for his research contributions from reputed organizations like Stanford University, International Federation of Information Management, Tata Consultancy Services, Project Management Institute, Association of Indian Management Schools, IIT Delhi, the BK Birla Group of Companies, and IIM Rohtak. And in terms of his core academics, he is an engineer from Jadavpur University and a gold medalist at that. And he has completed his master's and doctorate from XLRI Jamshedpur. Dr. Arpan, tremendous profile, and please allow me to compliment you for that. And I would now like to hand over the floor to you, Dr. Arpan. So like we discussed, if you can share your thoughts for 35-40 minutes, post which we'll open up the chat box for a Q&A with our participants. Dr. Arpan, over to you. The floor is all yours.
Thank you. Thank you so much. I think it's really a pleasure and a privilege that you decided to host me. Professor Raman, Professor Yogesh, Professor Bhattacharya. It has been really nice to be part of this, lecture series on AI. And when I got this opportunity to share a little bit of my perspective in this session, I think this is something that will stay for a long time and will be very impactful as a seminar series. And thanks for the invite. And I'll try to not share too much of time or take too much of time in terms of other discussions, and I'll deep dive into the topic. So the topic that I'll be kind of focusing on is how AI/ML emerged, how it evolved, and subsequently the growth of application and adoption in enterprises. So, as has been already kind of mentioned, in my research every year, I typically have 2 kind of focus areas. One is focusing in the business journals. So probably 80% of my publications focus on business journals, but 20% of the publications which are there focus on computer science journals. So today when I'm actually giving my perspective here, I'm trying to wear both the hats. Of course, majorly is there in the information systems journal, but a small part is also there in pure tech journals, which are there. So today when I'll be talking about, the artificial intelligence, I'll be talking about what is there from the technical perspective and how that eventually flows into the functional perspective of AI. So fundamentally, as like Professor Yogesh has already shared, AI is something that is not very new. But then these days, artificial intelligence is kind of drawing a lot more attention than it used to do probably a decade back. So when we are talking of intelligence, predominantly artificial intelligence is characterized by, a system which will have some capabilities, for reasoning, learning, and adaptivity. What do I mean by reasoning? So if I give certain instruction to somebody, the person receives their instruction, reasons it out, and takes an action. Similarly, in artificial intelligence, if there is an input, if there is an instruction that is given, there'll be a reasoning logic which is embedded in the system on the basis of which an automatic, decision and outcome is basically presented. Similarly, when we're talking about artificial intelligence, it is characterized by learning. What I mean is, such a system would typically try to take inputs from the ecosystem, and then over a period of time, if the inputs from the ecosystem changes, then there is a learning that happens in the system automatically. And based on the learning, what happens is the system starts evolving, and the decisions or the output that it generates, that also starts evolving with time. And also adaptivity. So if there is a sudden change in terms of the ecosystem requirements, then automatically the system can adapt to that change and recreate the rules which are typically going out in terms of a decision making and focus. Now, this is what typically is characterized by artificial intelligence. But what happens a lot of times when you're talking about this domain of artificial intelligence, machine learning, and all this, a lot of times we tend to use algorithms which are not really into artificial intelligence, but characterizes some elements of artificial intelligence, but not probably core AI. But then this is how the area has actually evolved. So I'll start talking about its evolution. So when we're talking about this characteristics of AI systems, what we mean is an AI system should have, and if I go by classic definition of AI, which started evolving and becoming slightly more mature about 80s and 90s. Of course, the first set of AI systems started coming in the 60s itself, when it was purely a mathematical formulation of what constitutes intelligence. But then when we are looking at AI systems, it basically would have the capability to extract knowledge, to store that knowledge. What do I mean by knowledge? So data, when it's getting processed, creates information. When information can be connected with a set of business logic or a business rule, then it becomes knowledge, which will be actionable. So in this journey to the capability to extract and store knowledge, an AI system should demonstrate human being-like reasoning processes, the ability to learn from experiences, which is basically in an AI system often called as technically as the training. So from the data set that it receives, it will train itself and then, automatically generate some kind of output. So when we are talking about this, typically what has happened is this evolution of AI initially used to happen for structured data. What has happened is it has slowly moved towards unstructured data. So classic AI systems, when we're talking about it, mostly has been using a lot of structured data in which you have data that is typically in the form of numbers. A vector would be consisting of a series of numbers, and that vector would basically be a series of such vectors, would typically be a series of rows having different numbers, which will be taken in by the system, processed, and then some rule is basically created in the system and an output is generated. But here what has happened is, as we have evolved in AI, we started going more and more into different new models of how AI can process the data, in which areas which has become more and more prominent become something like natural language processing, speech recognition and synthesis, image analytics, or image mining. The way that we have been doing this analysis was still there about 2 decades back. For example, image processing, when we used to look at classic image processing, an image would be characterized by the RGB values, and that would be transcending in a vector. But what happened is, earlier we used to convert the image to a vector format, which is basically a numerical format, and then run the analysis on that. But now it is no longer to do that kind of a transformation or vector quantization that is called. But now the systems of AI has become so mature, you can directly operate and get the output, that desired output, with some degree of noise, of course, from these different types of data, different unstructured data. And that's what has basically evolved. So what has changed? So I'll try to elaborate a little bit, because these days when we are talking of AI or we are talking of machine learning is something that is slightly more classic. In the 90s, in the 210, we used to talk of machine learning more. Now, again, artificial intelligence has picked up as a terminology that is used more in the management journals. But artificial intelligence was also very popular prior to the 1990s, but had a bad phase where we started talking more of machine learning instead of using the term artificial intelligence. So this artificial intelligence or machine learning would typically capture the way that living organisms would typically, take and process some kind of input from the environment and then create some output. So when we're talking about this, if you're looking at a classic way, what are the needs of an organism, a living, organism? It could be a human being, it could be an animal, but then they're characterized by few basic needs. Just like we in the management, we have Maslow's hierarchy of needs. Similarly, we have some needs in a basic organism: the need to procreate, create the next generation, the need to forage, need to eat food, the need to excrete, the need to reproduce. So some of these basic needs, which are there in typically every organism, that is typically replicated when we're talking of this AI/ML algorithms. So what happens in the AI superset is we have some set of algorithms which are called as biologically inspired algorithms, some set of algorithms which we call as nature-inspired computing or nature-inspired algorithms. And in the interface of both, we have something that is called as multi-valued logic. So when we're talking about most of the algorithms, I'll be talking a little bit of the examples that I'll be talking in today's session is more towards the bio-inspired computing or biological, computing algorithms. Of course, there is another group that is nature-inspired computing. So the biological inspired computing would be typically replicating a living organism in the way that it, forages, searches food, tries to move to the next generation. And then there is the nature-inspired algorithms, which will typically try to replicate the way typical laws of physics would operate. For example, there are algorithms like simulated annealing, which will probably behave, which will try to understand the way that if a very hard molten liquid falls on some surface, what kind of properties inherently guide that liquid to take a particular shape. Similarly, there are another area of logic like multi-valued logic, which typically consists of areas like rough set theory, fuzzy set theory, and all this. So the interface on all this, the superset of all this, is basically what constitutes artificial intelligence. And the learning part of artificial intelligence is typically captured, the learning, the ability to learn, ability to adapt, is typically captured in the nature-inspired computing or the biologically inspired computing in these sets. And some of these sets, when they're overlapping, they're basically called as hyperheuristics. But in itself, some of these algorithms are basically meta-heuristics. They can solve problems which are very, very complex in terms of data. And over the years, what has happened is these algorithms have started evolving. So what has really started evolving? So if you look at it, as Professor Dwivedi has been sharing, this is a lecture sheet series on an article which brings out a lot of perspective in AI that was published in 2020. It is, I would say, an encyclopedia for AI. And my contribution in that was basically coming in from one article that we had published in 2016 in a journal that is Expert System with Application. We started talking about how has this evolution happened and what are these ML algorithms which have evolved over a period of time. So if you look at maybe the 1970s and the 1980s, we started looking at algorithms like neural networks and genetic algorithm. And typically, if you look at these algorithms, some of these algorithms have been used in, operation research kind of, OR kind of journals, if it is in the management discipline. Otherwise, they have been used in purely the IEEE transactions or the ACM transactions kind of journals. So if you look at these algorithms, the neural networks, the genetic algorithm, these are kind of algorithms which has actually witnessed, 30, 40 years of evolution now. And then there are algorithms like leaping frog, ant colony optimization. Ant colony optimization was by Carboga in 2000, around 2000, 1995, 2000. Then the particle swarm optimization, cuckoo search, bacterial foraging, these kind of algorithms started replicating the way that these individual organisms behave. For example, if you look at ant colony optimization, these algorithms started looking at the way that a colony of ants, multiple ants, maybe having thousands of ants, how they will go out of the colony, try to search for food, and then track back the direction they have come to reach the food. If the food has reached by a shortest distance, they track it using the pheromones, some signal, some smell signal coming out of the reproductive ability of the ants, and then track back which is the shortest distance for that food. So these kind of algorithms, which are biologically inspired, have developed over a period of time. And these algorithms, which have developed over a period of time, try to replicate artificially using mathematical functions, using mathematical signals, how we can replicate the way that nature operates, how we can replicate the natural intelligence that is imbibed in nature. And this is where basically it becomes more and more important and interesting that each of these algorithms which are there, they have a very different way of operation. For example, something like a cuckoo search would have something like revive flights in which a cuckoo would fly from one nest to another nest, trying to find a nice position to lay eggs, which is very strong and contrasting to how an ant would operate. But now what has happened is when we are talking about AI, all these different baskets, and this is only the bio-inspired computing basket, and there are multiple, a plenitude of other algorithms here. But these algorithms, what has happened was we started calling them the larger basket of AI. And in this, larger basket of AI, what started happening was slowly, as we proceeded with time, as the nature of the data, the size of the data increased, the volume of the data increased, the number of rows for each vector increased, then it became slightly difficult to address the problems with the classical algorithms like genetic algorithm or neural networks. So as a result of that, what happened was some of the newer algorithms started getting prominence. For example, when the data is really complex and it is typically in computational science terminology called as a multi-planar kind of a data, multi-dimensional data. So when that multi-planar data or multi-dimensional problem statement comes and it becomes a NP-hard problem, it has been seen that some of the classic algorithms could not solve it appropriately, but some of the newer algorithms, which are something like Firefly algorithm, started showing a lot of prominence in the way that they can solve the problem. And this is where the evolution in the academic community started happening, that the academic community started, the computer science community, I'm not talking of the business community as of now. So the academic community in the computer science, people like Xin Yang, all of them started looking at new algorithms which will try to replicate, the way these natural algorithms or this natural intelligence will try to replicate and capture the intelligence of nature. And this continued to happen, till 2010, 2015. And then we realized that there are some algorithms which are very mature. And some of these algorithms, like neural networks and colony optimization and genetic algorithm, especially these three, these became kind of adopted into the industry. These algorithms started getting more and more used in the industry, wherein some other algorithms which started looking more from the viewpoint of academic research. Some of the algorithms started looking more from the point of how to develop the theory, how to develop the functions which define the theory, how to define different new applications for some of these algorithms. But the zone of commercialization was something that was very interesting, because neural network and colony optimization and genetic algorithms started picking up in industrial application. And then this industrial application, what had happened over time, that these algorithms, within these algorithms, even neural network took a huge step. And this is only within the bio-inspired computing kind of a, cluster. There is, of course, the other cluster. So what had happened? In 2012, 2014, what had happened earlier, we were kind of, challenged. We were kind of challenged in the ability to process information, in our computational ability, which was commercially and easily available for us prior to 2010, 2005. And that was the time when we were kind of challenged in terms of how much processing power we had at our disposal. And post 2010, probably what had changed was this processing power was easily accessible using cloud computing. Using cloud computing, very high computationally, high resources, which had very high RAM, which had very high fast processors, they became available to us. And the traditional limitation, which we saw in some of the older algorithms, due to which, the academic journals started, kind of not publishing such papers which were using the older algorithms, and started publishing more of the papers which were using some of the newer algorithms like Firefly or maybe Lion, Krillhard, and all those. They started suddenly seeing some kind of a change. The change was now, because of the compute that was accessible, the data that was accessible, earlier the data was also a challenge, because some of those algorithms, to demonstrate its efficiency, needed the kind of data that was not really available in many of the business problems. But now with this digital transformation, what has happened was the digital transformation enabled people to get a huge amount of data, whether that is customer data, whether that is supply data, whether the data is there within the enterprise surrounding internal operations, internal exchanges. This, started demonstrating a huge potential. And due to which, what happened, the organizations which had the compute, the organizations which had the data, they could use the data, they could use the compute, and they could use the classic algorithms like neural networks for doing a lot more. And then suddenly there was a huge change in the research direction that was witnessed in the AI space, in the technical AI space, where a radical change went, especially in the space of neural networks. So what happened? So in this hijacking, in this sudden change, neural networks became the most prominent player. And then, other algorithms like decision trees and random forests became popular. Then logistic regression, surprisingly, because it is not, if you call typically an algorithm which will have the ability to learn, ability to have some kind of adaptivity, logistic regression typically does not allow that. But then in the industry parlance, a lot of times this logistic regression became very, very popular. Algorithms like k-means and knn, which are distance-based, they became very popular. Support vector machines, naive-based classifiers, they became very popular. So what changed? So this hijacking was typically done because the compute and the data was available in such a way that these algorithms, which were earlier restricted, which were earlier challenged, in the way they could, provide a certain, suitable, response or a suitable outcome, that completely changed. For example, if I deep dive into neural networks, there were deep learning, convoluted neural network, recurrent neural network, all these variations came in. And all these variations could be introduced or could be applied in domains where there is a huge amount of data, whether that is data for images using CNN or deep learning even, or data for maybe audios or videos using recurrent neural network. Things like adversarial learning came, as a recent thing. Google introduced BERT, which became a recent thing for natural language processing. So BERT became very popular. So what really changed is that these algorithms suddenly came in packages. I did not need to know what was there in the box, but the box was available to me. The compute was available to me. The data was available to me. I suddenly had a magic box in which I can throw in the data, put the box on a high performance compute, and then suddenly the box will generate outputs which I could not earlier fathom how it would, do so. And that's what kind of, evolved and changed when we started looking at, the space of AI/ML. So now these AI/ML started looking at what kind of applications can I, do using these algorithms. So within this, predominantly algorithms or objectives which were becoming more and more, popular, became focused on the clustering classification kind of algorithms and association rule mining algorithms out of this entire perspective. And then when the cognitive science became more and more popular, the cognitive science as in it became more and more popular with the advent of social media, advent of, Google, when we started talking of the cognitive, space, the semantic web became popular with Google, the semantic web 3.0 became popular with Facebook. Then we started looking at new areas of applications coming in network science, in text mining, in image mining. And this is where basically AI started evolving. And in this evolution, a lot of domains became popular. How do we define real versus fake? How do we define, suitable versus unsuitable creditors? How do we define people or customers who are going to churn? All this application domain became more and more popular. How do we define which content is real, which content is false, which content is real, genuine information, which content is, misinformation? These kind of areas started getting a lot of traction. But what is there when we look at it as an information systems perspective? When we are talking from a business perspective, the methods that are there, the algorithms which are there, are traditionally or typically clubbed together as a whole cohort. But this whole cohort has very different approaches. But then this whole cohort, a lot of times, because of the amount that is too huge, the number of algorithms are too huge, we would generalize them using the same terminology, saying that it's all artificial intelligence, which it is, of course, but then there are differences. So what happened? If we look at, say, some of our recent papers, we realize that when AI gets adopted in enterprises, depending on the context of the use, the AI algorithm would be different. Now, depending on the context that is being adopted, because AI algorithm would be different, maybe some of the characteristics of what creates that adoption becomes different. So from the perspective of stakeholders also, for example, business owners would typically use AI for efficiency, innovation, fast tracking research, establishing novelty in terms of the business processes, and facilitating automation, which leads to AI adoption. But then from the application owners, probably they look at features like, how emotive the element is. Then subsequently, if it is something that is interacting with customers, how emotions are getting replicated, how much of support it provides, what kind of an experiential learning that algorithm will provide. And depending on the algorithm, basically the experience of that, the adoption of AI will be impacted. So we started looking at in different of our research, what creates this understanding or what creates this experience in AI. We found that some of the experiences come from the degree of control that a customer has when he's using this, solution. The degree of control when he's using the solution, in our context, that solution is chatbot. So a chatbot can be implemented in different approaches. But when a customer is using that chatbot, the factors which are associated with the interaction when the customer is interacting with the chatbot, that overall impacts the customer's experience and then subsequently the adoption. If the experience is positive, then automatically the adoption happens. Similarly, there are touch points specific in the journey. In the customer journey, there are specific touch points which are relative to the service quality and customer satisfaction, which impacts the customer experiences. Similarly, there are elements in the system design perspective, which are coming in from the design science perspective, how the chatbot is, what kind of interaction or time distortion happen when chatbot responds back. So these are elements in how, the AI which gets adopted in enterprises, they continue to fluctuate, they continue to have an impact. But what is challenging is all these factors which we are considering for an AI would differ based on the context that we are exploring. So what is really relevant for a chatbot-based adoption, might not really hold true if we are looking at an adoption context, which is something like in a B2C enterprise, or maybe it's an adoption context in some other application. So this application specificity of, the algorithms becomes important to understand when we're talking of adoption in enterprises. Similarly, if you're talking of, this is also one of our papers, which we try to understand from multiple perspectives, one perspective coming in from academic literature, another perspective coming in from, the social media discussion, where we are trying to kind of capture the collective intelligence of all the people who are talking about AI in operations and, in operations management in manufacturing firms. So we saw that based on specific, stages in the operations, whether that is manufacturing, whether that is product development, whether that is services, whether that is supply chain, specific focus areas emerge. For example, in manufacturing, the focus area in terms of usage of AI is more towards the amount of data that is getting captured. When it is something related to product development, things like the algorithm part gets highlighted too much. What kind of algorithm help in terms of product development? And in that, if you look at the algorithm, it is very easy to understand that we are talking about algorithms which are kind of useful or dominantly used in the space of cognitive sciences, unstructured data mining. So they will be mining text, they'll be used for NLP, they'll be using for video mining. So these are more dominantly used for product development. So we see that there is a mapping depending on the nature of usage and the kind of prominence or the discussions that happen in the industry and in the academia. So when we try to kind of infuse all of that and we try to bring it into one platform, so the adoption literature of AI has a huge potential that is there. Because right now we are only scraping at the, at a very initial level, because we are not really distinguishing between the algorithms. But depending on the application, if we start distinguishing on the algorithm part of it, then what would eventually happen is the factors that we are gaining prominence in a particular application, that would change. But the challenge is, how do we get the data? How do we get the data that will be large enough for generalizability about the algorithmic application? So many of these challenges come into the research perspective when we're talking about it. A huge part of AI, we are talking about, for example, explainability of the outcome. So a lot of research has been undertaken right now on the space of explainable AI. Now, a lot of times what is happening in this policy research is AI is treated as a black box where some input is given and an outcome is achieved. but it's not really so. Some algorithms of AI are more explainable as compared to other algorithms. For example, a neural network might operate as a complete black box, but a decision tree, on the other hand, a decision tree based regression or a decision tree itself would have higher explainability. Similarly, when we're talking about the AI would enable a lot of benefits to the users. But then the AI is using a lot of data, which sometimes the users are not really, knowledgeable about that how their data is getting used. We love the services, no doubt about it. We are loving when we are experiencing the things in Facebook, when we are liking the content that keeps, coming back to us in Facebook. But then maybe at a point of time, there is a little bit of debate that is going on. In fact, quite a large debate. What is the ethical use of data? To what extent the consumer knowingly allows the use of data? If you're using the data, to what extent your privacy is preserved? So in the 2005, 2010, the privacy preservation in AI, that became a huge research area. And now also this is kind of percolating in the management disciplines. How much of personal information you would like the algorithms to use, and what is the trade-off? Because the algorithm uses personal information, then subsequently what happens is the service quality of the system enhances. It becomes more personalized in terms of the service that it delivers to us. But in that context, what is the trade-off that we are getting as a customer? Am I able to appreciate the trade-off? What is the transparency of outcome? If I get something as an outcome from the system, do I know what is creating that outcome? What is the fairness and trust on the system? Do we trust the system? If the system creates a falter, if the system creates an adverse outcome, who do I blame? Do I blame the data, or do I blame the system? Do I blame the hardware? Do I blame the business rules which are embodied in the system? So all these have become hugely, areas which require a lot of problem and which requires a lot of, deep deliberation, which I'm sure will be done in this workshop. Another interesting thing has come up. For example, the human in the loop problem. So these days, suppose, and even in the days when it was called as an expert system, then also when we look at, the data which is there, the AI system uses the data, and an initial labeling happens, initial training happens based on labeling. What if the person who is doing the labeling is faulty? What if the person who is doing the initial training of the system is himself biased? Then the system also gets, biased in deciding the outcome. So all this, when we're talking of different applications of AI, need a lot more deliberation. And this deliberation ideally cannot be done at a very, very high level. One would need to look at the specific application of AI and the kind of differences in outcome that it creates. For example, if you're talking of transparency of outcome, it would be different if a system is being implemented with a decision tree versus a neural network. But then the application itself would decide whether to use a decision tree. The application requirements will decide whether to use a decision tree or whether to use a neural network. Now, depending on that application boundary, the contextual usage of information is very, very rooted. And this is where probably future research needs to focus on. And then that's probably a space which has a lot of potential in future. So I think with this, I'll stop. I'll be happy to take on any questions that might be there.
Thank you so much, Dr. Arpan. You're a very eloquent speaker, beyond being a very distinguished professor and researcher, extremely eloquently put. I particularly enjoyed your references to the bio-inspired computing. And it kind of took me back to a book that I had read many years ago by Malcolm Gladwell called Blink, where he has identified gut feel and instinctive responses based on universal intelligence programmed in our DNA for thousands of years. And I was kind of mentally balancing some of your bio-inspired computing examples and how they have now come through to inspire various flavors of AI across industry, across research. And of course, research drives industry, industry needs research. So it becomes like a virtuous cycle. So we will just open up our chat box now for questions and answers. And while we wait for our participants, our students to pose questions, perhaps let me start with posing a question to you. If you kind of view the world around us, what are some of the leading use cases of AI that you feel has huge potential to transform business? We come from a B school, so that's a classic B school question for you.
So I think the applications of AI when it comes to automation, this is kind of going to be huge. I mean, in the operations, especially with Industry 4.0, with automation, a lot more these automated systems will be using AI. That's one thing for sure. So Industry 4.0 powered with AI and blockchain, that's going to be hugely there in the manufacturing industries. Also in the, so the digital industries, there's a huge amount of potential that is going to be there. So today, like I am also, involved as an advisor to a firm which is in the ad tech industry in US. So when we're looking at this industry, because this industry uses a lot more, digital content, unstructured content like images. I tweet an image, I try to make some meaning out of it. So the systems would automatically try to understand, positions, posts in Twitter, posts in Instagram, the ad tech platforms which are there, they try to run on these and use a lot more of these deep learning methods to make some meaning inferences out of video and images. So the cognitive sciences space, whether it is platforms like Google or Facebook, which are already, superstars in this market, but there is a lot of innovation which is happening in the cognitive sciences space, which I feel could be hugely there, huge potential there to impact the lives of individual. I'll give an example of a kind of project that one of my students is doing.
Please.
He's basically created an application which records on a real-time basis people whose kids are having developmental disorders. Now, at a point of time, if the kid is being recorded, and then at a point of time he requires some kind of a medical intervention, and when is that point of time when he requires that medical intervention, the system can automatically tell the parents. Otherwise, what would happen is the parents would periodically, every 3 months, visit the doctor. Is my kid all right or not? So this is a space that cognitive, sciences is actually throwing up. Earlier, when we looked at cognitive sciences, we used to look only at Google and Facebook. But then now, what's happening is the space of, monitoring, then on a real-time basis giving feedback, on a real-time basis creating providing medical impacts or social supervision and all that. I think that's also one space that will go up. So the health tech space, I feel, with cognitive sciences is going to burst very soon. One space is the ad tech, which is the digital and social media.
Yes.
One space is the health tech, I feel. And of course, Industry 4.0 is going to be hugely revolutionized by AI.
Thank you. Thank you. So we've started receiving questions on our chat box. So let me pose these questions to you. We have a question from Soumya Srikumar, who's from MBA 1 HR batch of SIBM Pune. So she writes, thanks a lot for such a wonderful session. My question is that how do we see the future of AI in terms of whether it is going to completely replace managerial decision making or just be a facilitator?
I think there is a huge amount of debate on future of work. So, there is a lot of discussion. In fact, one of the papers that one of my students presented in this year's ISIS was on this direction, that today AIML is being, AIML, blockchain, these technologies which are there, they are, evolving at such a huge pace. And then there is also a lot of apprehension surrounding what kind of jobs will it replace. But what is going to happen is probably the replacement will happen for jobs which will be repetitive in nature. So if there is a job that is repetitive in nature, which does not require too much of human intervention, then probably those jobs, yes, it might be possible to replace those jobs. And unless government comes in and steps in and tries to protect those blue-collar jobs, there's a chance that in the next decade, some of these jobs will be different. But what's changing is the nature of new opportunities that will be created. That's going to be there. So it's not that human intervention is going to be, or the management will be completely changed, but the managers need to be evolving quickly. So if you look at the traditional learning literature, if I look more from a OB point of view, so traditional learning literature a lot of times says that a human being during his, kind of professional career can learn and learn 4 or 5 times. But probably with this AI coming in, the need to unlearn and relearn something new, that needs to expand more than that. What was okay, maybe learning and unlearning 4 times or 5 times, and I passed my way 30 years in the career, probably that's not going to work out. And probably every 5 years or every 3 years, we need to unlearn, we need to relearn. And whenever that learning happens, the learning of skill distance happens, a lot more things will come into the picture. And that's where a lot of theories of adoption also comes into the picture. This demonstrability of what I'm learning in terms of AI, how that is going to impact my immediate, skilling and my recruitment or my career prospects. Then similarly, what I'm doing right now, the skill distance. So what I'm doing right now versus what I have to learn in AI, to what extent that is similar or different. If it is very different, I might have a lot of dissonance. I might have a lot of cognitive dissonance trying to change my way of work.
Sure.
And these are areas which are coming in hugely as we talk of research. But yes, I don't think that human intervention can be completely done away with, but we need to rethink the way that jobs are defined. So if you look at, the Future of Work report, which has been given by World Economic Forum, they also talk about some of these elements that maybe AI will not, with the current, it will not be a terminator soon. It might not be a terminator soon, but we need to relook at how we are looking at jobs, how we are looking at the role of human being, the role of management in jobs.
Thank you. Moving to the next question, we have a question from Akansha from SDA Bocconi School of Management. So she writes, my question is from an organizational viewpoint, which is the democratization of AI. With many platforms and plugins available, how do organizations decide whether they should implement an existing AI platform or should they build it in-house? The classic
Hi, Akanksha.
make
Good
versus
to meet
buy.
here. So that's a very nice question, Akanksha. And, a lot of challenges is there surrounding AI democratization. And one of the firms, a Japanese firm, which is there, I have worked closely with them in the past. They have tried to create an e-market which runs on blockchain. And they're trying to create a market in which these AI plugins or AI things can be used as a blocks by sharing them and borrowing them. And depending on that, the business model, the builder of that block will get revenue. But what's going to happen is when you create such platforms which democratizes AI, you'll always have AI which is built for a larger, wider application. So for an organization which is going to use the AI in a box, for them the efficiencies and everything is going to be slightly lower because they're using it as it is in a box. But if you're going to build it in-house, then the efficiency is going to be better. The outcome quality will be much better. But then the challenge is to build it in the house and to contextualize it and create it. You need a large team who understands technicalities. You need to have a team which will be understanding how the AI algorithmic development happens. They have to be people with PhDs in data science or computer science. So that is costly. On the other side, using it as a box, it is, you get it in a very short time. You don't really need to invest time into creating the box. The box is as it is, but then the outcome quality differs. Now, this is one of the very key thing due to which some of the algorithms became very popular, because most of the algorithms that are available as a plugin, you just take, the code, you just take the code, the application is ready to run. You just put in, you just import that as a kind of box into maybe a platform like Anaconda, or maybe a platform like R, and then in the environment automatically it runs, so we don't really need to know what's there in the box. We use it as a hammer, and we don't really need to know what has gone into engineering that hammer. But if that hammer has to be really effective, especially for purposes which require high degree of calibration, for example, medical diagnosis, then you have to build that AI in-house. You cannot really depend on the box, because any small deviation that might happen might have a very strong adverse outcome. So I think that depends on the risk appetite and the risk zone the firm would be operating its business from. So if it is a low risk zone, maybe we can take it as a box. But if it is a high risk zone, I would probably, advocate that you should build the ML platform in-house rather than using something that's in the box.
Very, very nice answer. Very eloquently explained once again. Thank you so much. The classic make versus buy question. It'll never go away. It'll apply to everything that we can think about. Next question, Dr. Arpan, is do you see the current hardening of privacy regulations limiting the development of AI? This is from Frederick Boy.
So there is, of course, the challenge that the current privacy regulation kind of impacts the way that we use AI for specific data related projects. But then what has happened is, when you look at academic institutions, whether it is Facebook, earlier Facebook used to be more liberal about sharing its data. Now Facebook also still shares the data, but anonymizes the individuals. So the PII is basically removed. So one part of it is, do the efficacy of the application goes down? Maybe to an extent it might, depending on the application itself. What is the target or what is the objective of the application? But a lot of times, even if the PII is removed, because a lot of times what is happening in the space of Facebook and Twitter, we are working on the content. We are not working on the individual account. We are working on the connections that are made. We are working on the content that has been created. We are working on the images that have been shared. And that still is accessible to us. And if that is accessible to us as researchers, I think it's still a green field. But yes, maybe if we had the entire access to the data, as I said, the rich gets richer. So that will continue to happen.
Absolutely, absolutely. Which kind of leads to a very interesting question. This is from Bhaskar Chaudhary from MBA1 Marketing, SIBM Pune. So he says, thank you so much for this enlightening session. So when speaking about neural networking and AI, if AI is used to increase brand presence, influencing customers' perspectives, or used in collecting data and marketing, how does one decide if it's ethical to do so or not?
Okay, so in fact, this is actually a research question, not the ethical part of it, but the how can AI do this? So that is a research question even some of my scholars are working on. So what happens when we're working on these projects? If I talk of, say, Facebook project, so we are not working on, the customer or the individual's data, which is there in the private space. So if you're sharing something in the private space, I might not have access to that. But what do I have access to is what is shared in the public space. So if an individual is willing to share something in the public, then automatically, he's consenting to the use of public data of Facebook's terms and conditions. Now, there is another part of it. Is the individual empowered to disagree with Facebook's terms and condition? Because there is a huge amount of, uh, disparity of the relative bargaining power of the consumer and the organization that is providing the services. One. Second is whether he's empowered or, empowered psychologically or empowered in the sense that academically to understand the terms and conditions he agrees to. So there are lots of slices of those debates as well. But then when we are talking about what is accessible, what normally firms use is the information which is there in the public. So if, say, today SIBM launches this program in YouTube and there are 200 comments which come, or SIBM page today posts some parts in the Facebook and then there are 500 comments that are there in that page. Now those are in the public domain. So if somebody is, or an algorithm is used, or a company is using a mechanism to, whether it is SIBM doing this analysis or whether that's a competing institute which is doing the analysis, if it is in, say, in some other industry, say it is a automobile industry, Maruti launches a car, and then BMW does an analysis, or maybe Mahindra does an analysis, that data is accessible and available for everybody because it's in the public domain. And that's where predominantly the customer's perspective in marketing is being used. The customer information, the customer intelligence is used for, doing marketing, whether it is for new product development, whether it is for new customer acquisition. I understand this is the customer which is most liable, most viable for me, or most likely to switch to my product or service. All those things are there. But whether it's ethical, yes, the ethical debate will be there. But then the customer is agreeing to the terms and conditions when he's going to post something in the public domain. But yes, the other debate is when he's agreeing to the terms and condition, what are the other challenges? Is he able to appreciate the privacy elements of it? So there is a very nice photo that, 30 years back, we used postcards which had both their sides open and we were happy sending those letters.
Correct.
And probably the biggest, invention that happened, we suddenly had a blue envelope where we can fold it and something could be written inside it. That's probably when we started deliberating about privacy a little bit. And now, of course, the privacy debate will come and the bargaining power, the relative bargaining power of the service providers and all, that will continue to be there. That debate will be there.
Absolutely. Thank you. So we are kind of running short of time, but we have so many interesting questions. So maybe I will pick one more question. And I think this is probably from one of your students. So Umar Mir from IIT Delhi is asking, Professor, how will you summarize adoption of emerging technologies like AI in the Indian context, especially in the public sector, as compared to developed countries? Umar Mir from IIT Delhi.
Yes, Umar. So when we are talking about adoption of emerging technologies in the Indian context, especially in the public sector, the drivers are different. So when you're talking of AI in the private sector and AI in the public sector, the drivers are different. So elements like how explainable is the AI is going to be a huge thing. How, for example, if I'm running an algorithm and I'm trying to give an outcome, say it's a classification algorithm, I say that this person is eligible for a loan or this person is not eligible for the loan. But I run the algorithm again on the same data set, then that classification might change. So what I'm labeling as an eligible person might become ineligible, might become if he's in the bordering case. But in a government perspective, that is something that will not really hold true. So the accountability, the transparency of AI, the explainability of AI. These might be very, very huge factors which will kind of, either promote or even deter the application of AI kind of algorithms. Of course, if you're talking of other, technologies like blockchain or IoT, that will be completely different. Vis-a-vis, if you talk of developing economies, probably public policy which will be there in place surrounding data, the usage of data, the guidance of adversarial outcome, on who lies the liability if there is an outcome. Those are somewhat defined in SLAs also, the service level agreement between the different service providers. And that's what probably in an Indian context we need to come up, and probably that's where probably a lot more, excitement will happen over the period of time.
Thank you. Thank you, Dr. Arpan. So we are running short of time, and I can see Professor Yogesh wants to speak. Yes, sir. Please, Professor Yogesh, please do go ahead.
Just wanted to add that in India, actually, it's already happening. So Tamil Nadu government has already created a policy framework, ethical policy framework for AI implementation. And there are clear areas, for example, transparency, accountability, and many other areas are part of that policy framework. So, I think if government organization going to develop and deploy AI applications, they have to follow those factors, otherwise they won't get approval. So the challenges are there because these are some of those things that Arpan mentioned, that these applications has to fulfill those criteria. So it wouldn't be easy to deploy, but then that is very important that those issues are actually accounted at the beginning in order to avoid issues. Biases, we all talk about biases in the AI output. And we have some very critical example that been highlighted in waste. For example, AI can easily identify white faces, but not the black, and many other such examples are there. And this is simply because how AI has been trained in terms of what data has been fed, who has labeled and how they have labeled those kind of data. So I think those factors matters, and those need to be regulated, and therefore AI governance comes into picture. And I think some of those talks scheduled in future will talk about these things. In fact, the Tamil Nadu government policy framework, the person who developed it, he will be talking as well in this AI series. Indeed. So hopefully you will hear more about it.
Indeed. We have his session on the 10th of March.
Absolutely.
So that's Mr. Santosh Mishra, the CEO of Tamil Nadu e-governance cell, and we'll hear a lot more details about it. Professor Yogesh, any closing remarks that you would like to make?
Absolutely. I guess some of those, first thing, thank you, Arpan. Wonderful session. It's an overview. I can understand it's a first talk and how much pressure you must have had in your mind, but it went very well. So thank you so much. And the point I would like to reiterate, lots of these AI related issues are not new, they are classical. The one that someone asked and Arpan explained, that should we use box or should we use a customized, the one that is developed in-house. This is obviously classical system development and acquisition issue that I have actually studied and taught to my students, that should you should you develop a system in-house, then what are the factors to consider? You have long, you need 2-3 years to develop the system. You need more cost, and not necessarily that system will be used, because by the time you finish that system development, probably requirement has gone obsolete. Yeah, and then other side you have then packaged solution where you have issue of fit actually. So packaged solution are standard and they may or may not fit exactly to the requirement that organization has. And And same applies to AI actually. Do you need actually transparency and reliability and other things that fit to your requirement? Or you're looking at cost effectiveness, where packaged things can come and easily be done. So I think some of those are classic issues that we really need to, our students and our colleagues need to think and how that can be actually applied to AI developments and management. And some of our unique challenges, obviously, we didn't have to think so much about privacy, transparency, accountability before, but now that are so dominant. So the point is, the whole purpose of this series is to create a bit of awareness. These seminars aren't able to provide in-depth understanding of any particular aspect, but what is the purpose that we get awareness of wider issues that is related to the AI developments and implementation. So hopefully Arpan has managed to give some of insights that are valuable, and obviously some of those questions he has answered are also very insightful. And let's look forward to look at other issues in future seminars. Thank you.
Sure. Thank you so much, Professor Yogesh. Dr. Raman, any closing remarks from your side?
Thank you so much, Dr. Arpan, for that introduction seminar series. As I told you, you are the opening batsman, giving the details about the evolution of AI. I'm sure there are a lot of questions that are there in the chat window yet to be answered.
Yes.
I mean, we will try to post them to you and see if you can possibly give some insights, so that we can also add that while we post this video on YouTube. But I don't know whether it will be possible to answer all of them, but if you can do some justice to a couple of questions, that will be nice. Thank you so much. I think, Professor Sandeep, we can now close today's session. Yeah.
Sure. So heartfelt thanks once again, Dr. Arpan. Many thanks. And it was an absolute eye-opener to hear you speak. Professor Yogesh, Dr. Raman, thanks for organizing this and conceiving this whole series of seminars. And last but not the least, I would like to thank all of our participants for their active participation, their active questions. There are still 137 people on the call. Thank you very much. Our next session will be in 1 week's time on the 27th, when we will have Mr. Vasilis Galanos from the University of Edinburgh speak with us. Thank you once again.
Just to add that, next
please.
session will be heavily focused on the ethics aspect.
Okay.
How ethics plays role in the construction of AI, basically.
Wonderful. And we'll have the researcher from the University of Edinburgh, another iconic and famous institution in the academic world. So we really look forward to this entire series. And Dr. Arpan, if you can spare the time, please do feel free to join some of the other seminars as well.
Thank you for such.
Before we close, Professor Yogesh and Professor Arpan, the e-frames have been sent to your mailbox. Thanks to my student team, the iSmart team, which captured and have created it. I'll be glad if you could post that on your LinkedIn handles as well.
I'll definitely do that.
And I must also thank Mr. Rajesh Bagewadi and his entire IT team for supporting us with the entire IT infrastructure, which has enabled this session to run so smoothly. So thank you one and all, and wish you all a very good evening. Please.
Can I just say that many of my colleagues have joined from Swansea University's School of Management.
Okay.
So I just wanted to thank them for being here.